Hey everyone, welcome back to the channel Infinity by Yashaswini. Today we are dividing into something super cool in mathematics, that is Euclid's division lemma. You might be thinking, isn't this just boring division stuff? But trust me, it's not. By the end of this video, you will see how this simple concept unlocks secrets of number. And yes, it's the foundation of finding HCF and so much more. Euclid was a Greek mathematician who lived over 2000 years ago, and guess what? He gave us a simple way to divide numbers neatly and gave us a brilliant simple way to describe division. And his idea still forms the backbone of number theory today. Let me explain the theory. For any two integers a and b, with b greater than 0, there exists a unique integers q and r such that a is equal to bq plus r and r is greater or equal to 0 and less than b. I know that if I say only theory, you won't understand anything. So let me explain step by step. Here see a and b are the integers where a is a bigger number, that is a is a dividend and b is the another number, that is divisor, and q means it is a quotient and r is a remainder where the remainder is less than quotient and greater or equal to 0. So let us take one simple example. If you are dividing 13 by 4, here 13 is a dividend, that is a. A is equal to 13 and B is a divisor, means 4 is a divisor. So B is equal to 4. So when you divide 13 by 4, 4 3 times is 12 and 1 is a remainder. So remainder is R and the quotient is Q. So which is in the form of A is equal to B into Q plus R. So here A is 13, therefore 13 is equal to B is 4, 4 into Q is 3 plus R is 1. So we can write this as 13 is equal to 4 into 3 plus 1. We written according to Euclid's lemma. In the same way, if you take 29 divided by 7, you know that 7 4 times is 28 and 1 is a reminder. You can write it as 29 is equal to 7 into 4 plus 1. This is simple, right? You know this is according to Euclid's division lemma. Here A is equal to B into Q plus R, where A is a dividend, B is a divisor and Q is a quotient and R is a remainder. Let's solve an example. Imagine you have 17 chocolates and you want to pack them in boxes of 5. How many full boxes can you make and how many chocolates will be left? So here 17 is the number of chocolates you have. So you can take it as 17 as A and you want to pack in each boxes 5 chocolates. So 5 is equal to B. 17 is a dividend and 5 is a divisor. According to Euclid's division lemma, A is equal to B into Q plus R. So if you divide 17 by 5, you will get 3 full boxes because 5 threes are 15 and you left over with 2 extra chocolates. According to Euclid's division lemma, how can we write it? So we can write it as 17 is equal to 15 into 3 plus 2. So we divided 17 chocolates as 5 chocolates in each box, like in 3 full boxes and 2 chocolates remaining. Let us solve one more example. Imagine if you have 29 apples and want to distribute them equally among 6 children. How many does each get? How many are left? So here the number of apples, so A is equal to 29 and B is 6 children. Among 6 children you have to divide. So B becomes 6, that is divisor. So when you divide 29 by 6, 6 4 times is 24 and 5 is a remainder. How can we write? According to the Euclid's division lemma, that is A is equal to B into Q plus R. This is quotient and this is remainder, that is 29 is equal to 6 into 4 plus 5. And the condition is the remainder should be less than B. So the remainder is less than B. Why do we care about this? Euclid's division lemma is the foundation for finding HCF. that is highest common factor of numbers, solving diaphanite equations, and understanding number theory. Without it, we cannot move forward with some advanced math concepts. Think of it like learning the alphabet before writing a novel. Now let's take 23 and 7. Divide 23 by 7. 7 3 times is 21 and 2 is a reminder. So here A is 23, B is 7 and Q is 3 and R is 2. So according to Euclid's division lemma, we can write it as A is equal to B into Q plus R. So it is 23 is equal to 7 into 3 plus 2, and the condition is R should be less than B. Here also 2 is less than 7. So the condition satisfied. Now let us take a slightly bigger challenge. Divide 107 by 15. Here 107 is A and 15 is B. When you divide 107 by 15, 15 7 times is 105 and 2 is a reminder. So according to Euclid's division lemma, A is equal to BQ plus R. We can write it as 107 is equal to 15 into 7 plus 2, where R should be less than B. Therefore, the condition satisfied. Now it's your turn. Pause the video and try 58 divided by 6 yourself. Got it? Let's check together. If you are taking 58 divided by 6, 58 is a bigger number, so it become A and 6 is become B. Now what we are doing? We are dividing 58 by 6. 6 9 time is 54 and 4 is a reminder. So this become quotient and this become reminder. So step 2 is Q is 58 divided by 6, that is 9, and the last step is, and we have reminder 4. So according to Euclid's division lemma, we can write it as A is equal to B into Q plus R. That is B is 6, Q is 9 and R is 4, and the condition also satisfied. Here is where it gets interesting. Euclid's lemma helps us to find HCF efficiently. Let's find HCF of 107 and 15. First, let us divide 107 by 15. So 15 7 time is 105 and 2 is a reminder. Like this, till you get 0, you have to divide. And in the next step, now divide 15 by 2. 15 7 time is 14 and 1 is a reminder. Now again divide it. So 1 2 time is 2 and the remainder is 0. Till you get the remainder 0, you have to divide. So we can write this using Euclid's lemma. That is, in first step, 107 is equal to 15 into 7 plus the remainder 2. Now in the second step, 15 is an A, that is 15 is equal to 2 into 7 plus the remainder 1. And the last step, 2 is equal to 1 into 2 plus 0. So when you get 0, the respective B, whichever is there, that become an HCF. So here HCF is 1. See, one small lemma helps solve a big problem quickly. Imagine a king is distributing coins among villagers. Some coins are left after giving each villager equal shares. That left over is the remainder R. The full share are quotient Q and the total coins are A. So here the total coins are A, equal share among the villagers is B, number of coins each villager receive is Q, that is quotient, and the leftover coin are R. Euclid's basically said no matter what, you can always express the total like this. Isn't that cool? Always remember one thing in Euclid's lemma, that is, remainder must be smaller than divisor. Never forget that the remainder should be smaller than the divisor, and it should be greater or equal to 0. Don't mix up quotient and remainder. We'll solve few questions how to find the HCF using Euclid's division lemma or Euclid's division algorithm, which are very important for your board examination. The first one is find HCF of 135 and 225 using Euclid's division algorithm. So while you are finding HCF of two numbers, the bigger number become A, that is dividend, and the smaller number become the divisor, that is B. Now divide 225 from 135. So 135 one time is 135. What's the remainder here? The remainder is 90. So this is quotient and this is remainder. So the first step is 225 is equal to 135 into 1 plus 90. Now the remainder become the divisor and divisor become the dividend. Now divide 135 by the remainder. So 90 one time is 90 and the remainder is 45. So in the second step, how we can write 135 is equal to 90 into 1 plus 45. Now divide this divisor by 45. Now 45 two time is 90 and the remainder is 0. Till you get remainder 0, you have to divide it. So the third step is 90 is equal to 45 into 2 plus 0. So when you get 0, the respective divisor become the HCF. So HCF is equal to 45. Easy, right? Whenever remainder becomes 0, the divisor at that step is your HCF. Now let us solve one more problem. Now let us find the HCF of 196 and 38,220. So here the bigger number is 38,220. It is A and B is 196. Divide 38,220 from 196. 196 one time is 196 and the remainder is here 186. Take 2 down. Now 186 9 time is 1764 and the remainder is 98. Bring 0 down. Now 196 5 time is 980. So you got the 0. Now here how we can express this according to Euclid's lemma means 38,220 is equal to 196 into 195 plus the remainder 0. So when you get the remainder 0, at that time what will be the divisor? That become the HCF. Therefore HCF of 38,220 and 196 is 196. Now it's your turn. Pause the video and find the HCF of 867 and 255. Got it? Let's check together. In the first step, the bigger number is 867. So you have taken 867 and divide 867 by 255. Then you got 102 as a reminder. Now the new pair become 255 and 102. Now divide 255 by 102. Now the new reminder is 51. Again you have to divide till you get 0. In the last step, whichever is the divisor, that become an HCF of the given numbers. So HCF of 867 and 255 is 51. Now we'll solve a very important board question. Show that any positive odd integer is of the form 2q plus 1. According to Euclid's lemma, A is equal to 2q plus r. Since the remainder must be less than 2, possible reminders are 0 or 1. The first case is if the remainder is 0, then the number become even. When the remainder is 0, what happened? The number become even number because whatever you multiply with 2 you will get even number only, so even number. If the remainder is 1, then the number becomes odd number because if you add 1 to the even number you will get odd number only. Therefore every odd number can be written as 2q plus 1. This is the answer. Show that a square of any odd number is of the form 4q plus 1. What they are asking here means the square of odd number is in the form of 4q plus 1. We already solved that one odd number, that is 2q plus 1. So let this become an odd number, and when we square this odd number, what happened here? 2q plus 1 whole square. You know that a plus b whole square is equal to a square plus 2ab plus b square. So according to this, 2q plus 1 whole square is 2q square means 4q square plus 2ab. 2 into 2q is 4q. 4q into 1 is 4q plus 1 square, that is 1. So in this, what is common here? 4 is common. When you take 4 as common, it becomes q square plus q plus 1. So 4 of q square plus q plus 1. Therefore, the square of odd number is always 4q plus 1. Show that every integer is in the form of 3q, 3q plus 1 or 3q plus 2. Using Euclid's division lemma, A is equal to 3q plus r. B is 3. So the possible reminders are 0, 1, 2 because r should be less than 3. Now, so that we can say that when r is equal to 0, this equation becomes 3q plus 0, that is a is equal to 3q plus 0, that is a is equal to just 3q. Next, when r is equal to 1, a is equal to 3q plus in the place of r 1. Then when r is equal to 2, a is equal to 3q plus 2. That's the solution. It's so easy, right? Here is some different level questions. You can try it and answer the comments below. Let us discuss some common mistakes that students makes. Students lose marks in very silly mistakes. The first one is writing the remainder greater than the divisor. You must remember that remainder should be lesser than the divisor. And the second mistake is mixing up q and r. Q is quotient and r is the remainder, that is which is left over. Then the third mistake is forgetting to verify your answer. Always cross check that a is equal to bq plus r. And the last mistake is using a negative number for r. As we know that the remainder should be equal or greater than 0, not less than 0. So remainder should not be a negative number. Let us summarize what we learned today. That is, according to Euclid's division lemma, A is equal to BQ plus R, where R is greater or equal to 0 and less than B, that is divisor. And we solved few problems according to Euclid's division lemma, and we solved few important board exam questions, and even odd integers, that is 2q plus 1 and 4q plus 1. These are very important for your board exams. If this video helped you, make sure to like, subscribe, comment your toughest chapter below. And if you want bilingual explanation in Kannada and English, comment below. I will make special videos for you. See you in the next math master class. Bye bye.